Okay, so let's look at our next tutorial about the sliding mesh. So that is about the topo pass rotating. Okay, so let's first look at the readme file. Okay, fine, just create the environment. Okay, first we look at the mesh and try to understand the test case, then let's see. So we are using the OF extended 4.0 version. Okay, and here is our readme file. So let's explore. First clean the case. Let's go for block mesh. Check the mesh, so it gives us the idea exactly how our test case look like. Okay, sorry, first if you see this class of error for paraform, so just we have to rename the 0 folder because still our all the boundary and everything is not set, that's why it's failing. That's it, nothing more problem. Okay, so this is what we have. Okay, so let's try to understand step by step. So this is the inlet portion. Okay, and this is inlet and this is outlet. Okay, so inlet outlet we have, then we have a few more rotor cyclic boundary we have, upper and lower. Okay, this is rotor cyclic upper and lower boundary we have. Okay, and along with that we have a stator cyclic also. Okay, so rotor and stator cyclic boundary we have. Then we have a here is moving wall. Okay, so this entire wall is moving. Okay, so it is called the moving wall portion. Again, just switching off and switching on. Okay, so if let look at one more time, this is moving wall, and if you switch off the rotor cyclic upper and lower, okay, so this is what we have, a moving wall. Okay, fine, so this entire wall is moving, so that's why it's called the moving wall. Okay, then we have a interface. Okay, let's look at parallel fixed wall. Okay, that is attached to the stator part, so this entire thing is a fixed wall, and let me switch off the stator part. So this other than stator part, it is a fixed wall, and in between there is a moving wall. Okay, so that is what we have a geometry. And then to couple the moving and stator wall, we have a interface. So interface 1, okay, that is attached with this moving wall. Okay, and then we have a interface 2, okay, that is attached with the fixed wall. Okay, so that is how we have a moving wall and the fixed wall interface we have. So interface 1 and 2 we have. Okay, so that try to exchange the data with each other. Okay, so that is what you see, overlapping zone. So one interface and another interface. Okay, it's try to exchange the data. So this is what we have as a geometrical point of view, inlet outlet. So let me summarize everything time. So here is the inlet, here is the outlet, this one. Okay, this is moving part, this is stationary part. Please understand, here we didn't consider entire of the passage, that means entire rotor and the stator. We just consider the segment of this particular portion. Okay, and we try to mimic the same thing, like entire portion is rotating with the help of this simple segment of stator and the rotor. So let explore how it going to work. Okay, so this is set. Now let's look at the bash file, so that give us the idea. So what we have interface 1, and from the interface 1 we construct the interface 1 faces, interface 2 we construct interface 2 faces. Okay, then we have a rotor cyclic upper. Okay, so what we do, we try to construct the faces out of this rotor cyclic upper and the lower. Okay, so that is what we're going to do. Let's look at again what, because why they're required, because we want to construct the GGI interface in between. So this is this 2 page So we also require the faces that is attached with this rotor cyclic 1 and 2. Okay, so that is what we're going to do here, cyclic upper and the lower. Okay, so we try to generate the few face set with the help of this set command. So let's explore this one command. Okay, so yes, so if you do that, so then just look at how exactly sets look like. So we have all the 4 sets ready to go. Now here we have discontinuous zones, so let's generate the different cell zones as well. So for that we have a, now if you look at, we have a 2 cell zones, region 0 and zone 1. So let's again go to the paraform and try to understand exactly what happened. So this is our regular thing, and if we include the sets, we have a few more entries here. So let me switch off this and let's understand. We have a, first is zone 0, okay, that is rotating zone, and then we have a zone 1, that is stationary zone, fine, and along with that we have a interface faces. Okay, this interface 1 and 2, we have a faces here. Okay, same way for the cyclic we have a faces here. Okay, so this is all we constructed as a face sets. Okay, so now after the construction of face sets, let's copy the face sets at appropriate location. So for that, let's use this one command, sets to zone no flip flap. If you do that, what going to happen? Look, rotor cyclic upper face goes as a phase zone, rotor cyclic lower goes as a phase zone, interface goes as a phase zone, this also goes as a phase zone, and region 0 and 1 goes as a cell zone. Okay, so that is what we copied all the sets into the proper zones, phase zones and the cell zones. Okay, so we are ready for that, but for run. But now let's explore the few setting here. So this is about that part. Okay, now let's look at the let's look at the boundary condition here, so it gives us the idea. So boundary condition, if we see rotor cyclic upper wall, okay, it is a cyclic GGI, okay, because we have to look at in the cyclic pattern, so that's why it's called cyclic GGI, and its shadow patch is rotor cyclic lower. Okay, and if we rotate by 30 degree, okay, then we able to reach this rotor cyclic lower wall. What it mean, please understand from the para view. So this is what we have, and let's switch off everything. We have a rotor, both the cyclic. Let me open that. Okay, so the in between distance, in between angle of the upper and lower this rotor cyclic wall is 30 degree. Okay, so if we look at the upper wall, okay, so again this is upper wall. Okay, so from upper wall to lower wall we have to rotate by minus 30 degree, and from lower wall to upper wall we have to rotate by positive 30 degree. So that is what we are setting here. Okay, and axis of rotation is 1. Same way from rotor lower to the rotor upper we have to rotate by 30 degree. Okay, and stator is the cyclic. We need not to change anything because it going to be stationary. Okay, same way interface we have overlap GGI. Okay, so whenever some portion or the entire some segment of the interface is overlapping, then we go for overlap GGI. Okay, so when we go with the overlap GGI, it's not necessary always both the interface is at 1-to-1 locations. Okay, it without it is at the 1-to-1 location, it try to exchange the data. So that is the very nice interface we have. So overlap GGI for interface 1, and shadow patch is interface 2, and the cell zone is interface phase zone. Same way overlap GGI for interface 2. So for that it is a overlap. Why it is called overlap, please understand. So if you look at here interface 1 and 2, okay, it not exactly mapping 1-to-1. Okay, if you look at the some portion is overlapping, this portion is overlapping. So let me switch on and switch off. So this is this part. Okay, and now just look at the this part. Okay, so some portion is overlapping, but when we start the simulation, you come to know that entire of the rotating off portion is come out of this interface until we have an exchange of the data. So during that time we go with this overlap GGI class of the boundary, and it is a very nice way to exchange the data between this patches. Okay, so what we did, we first look at the block mesh and try to construct the mesh file. Okay, then we try to use this set batch to create the interface face sets, then region cell zone to create a one or mesh non-connecting cell sets from the mesh zones. Okay, then we use this set to zone no flip flop options, okay, to transfer set to zones and without modifying the face normal or doing any modification in the cell zones or phase zones. Okay, so that is what we did here, and now we want to run it, but we try to run it in terms of the in terms of the parallel computing. So let's observe few options here. So when we want to decompose the case as far as the parallel computing is concerned, so look at the decompose para options. Okay, and here global faces, we have to whatever the places where we have interface. Okay, we supposed to specify all patches as a name as a global face zones. Okay, so during the parallel computing they have to take care about this all the interface, okay, about the data exchange. So that's why we have a this global face zones as a options available. Okay, and then we have a domain decomposition by 4 processor, and Scotch is the method, and 2 in x and y directions. Okay, so this is how one can decompose the case. So let's now decompose the case and start running this one case, so at least we have idea. Okay, so it is not necessary you also decompose and run, you straight away run as it is, but if you want have a multiple processor you can decompose. Okay, and look, when we are decomposing it, take into account this one. So initializing the GGI interpolator between the master and the shadow patch. Okay, so it try to take into account all the global patches. Okay, so wherever they require some interpolations, they have to take into account these portions. Okay, so explicitly we have to specify at what location the grid interface is required for the parallel computing point of view. Okay, so we have to take into account that, and let's now run the case for, let's say, on 4 processor, and let's see how it's working. Okay, sorry. Zero folder is not available because I rename it. Okay, that's why it's failing, nothing problematic. So let me rename the 0 folder. Okay, and let's go for decomposition again. Okay, so it's running with the 4 processor. How I know? If you type a top command here, you will see the 4 icodynamic form as a exe file is running. Okay, that tell us that okay, there is a total 4 processor that is working on that. Okay, so this give us the idea how exactly the simulation is going on with the help of that. Okay, so so we have to wait for another 10 to 15 minutes, then be able to look at the data. So let me check how the simulation is going on. Okay, so let's observe the progress. So we started the calculations, let's say here. Okay, so time equal to new time. Okay, and now first we go for this volume continuity error, and then we look at the convergence of momentum equation, then multiple pressure corrections we gave. Okay, then what we look at is few more outputs, like you mean here we didn't kept the GGI check, that's why we not able to see the output of the GGI. So what I mean, if you look at the control dict file, okay, so here if we specify the GGI check, okay, then it give you the idea about the interpolation between the all the GGI patches. Okay, if you require, you can type that GGI patch. Okay, so that is sometime very useful to look at the interpolation between different patches. Okay, so if you want, you can copy that GGI check from the previous tutorials and kept it here. Okay. We have a adjustable runtime, and core number we make sure is reasonably low. Okay, so let's explore meanwhile few more options here. Okay, so we have a piezo based algorithm. Okay, and also let's explore the boundary condition area. Okay, so we have a U and P. Okay, and here surface normal velocity. Okay, so inlet, from the inlet we are specifying the surface normal velocity. Okay, and this is short of dummy value, so don't worry about this part. Okay, then we have a outlet, zero gradient, fixed. Now moving walls we specify as a moving wall boundary conditions. So in the last discussion I told you about that boundary conditions. Okay, so we have a couple of options about the moving wall. So when we talk about the moving wall velocity, only normal component with respect to that moving wall we are retaining, so that is what we use. Then all other places we have a cyclic GGI or cyclic or the overlap GGI. Okay, so this is all the boundary conditions we have. So with the help of that we able to run the case. Now let's see inside the processor how many backup file we have. So let's try to reconstruct the para. So if you type the reconstruct para, and if you want to reconstruct each and every file, so you can straight away type that. And let's now look at the results. Okay, so this is what we have. Okay, and here is the input first file. So look, it start rotating. Okay, and how it's able to rotate, it is defined in the dynamic file. So let's look at this. So dynamic FV mesh, we are using the turbo FV option. So for turbo machinery, this is a dedicated dynamic FV mesh library available. Okay, so we have a coordinate system cylindrical in nature. Okay, directions. Okay, then axis and the origins we have. Then with the cell zone 0 is rotating at a 60 rpm, and we have a interface. Okay, interface sliders. Okay, so that is also rotating at 60, and the rotor cyclic is also rotating at a 60. So all these patches that is attached with these zones, okay, that is rotating at a same rpm. So that is what we are specifying, and with the help of that we able to mimic this rotating effect. Okay, so let's wait for few more moment and let's see how exactly it is going out of this thing. So let me reconstruct by time wise. Okay, time equal to 0.09 till let's say 1.5. I don't know how many it's over. Okay, so let's look at few more patches here. So now we able to look, it's almost detached. Okay, till it able to transfer the data. How? Because of this overlap GGI. Okay, because of this overlap GGI, it allows that to transfer the data. Okay, even though it is not one-to-one mapping. Okay, when it is rotating, you will see that even though it is not exactly on the same interface, okay, then also we able to take the interpolation of the data from one patch to other patch, that is from this patch towards this patch, even though it is not one-to-one map. Now it is completely out of the interpolation. That means it's completely way off both the patch, and till we are able to exchange the data, and that is because of this overlap GGI boundary condition for the interface 1 and 2. And when we specify it at the beginning, it try to construct the mapping between these faces. okay, all the faces and these faces, and with the help of that it try to exchange the data one to one, even though at a mesh is not exactly on the same locations, okay, because it's more like an interpolation only, so it's not necessary that mesh is also at the same locations, okay. So this is how one can take into account this very nice turbo FV mesh class of the mesh motion options available inside the OpenFOAM. And with the help of this overlap GGI, you can take into account the interpolation between the non-overlap patch as well, okay. So please try to run till 1 second, and you see that this entire rotating object is rotating by 360 degree, and even though it is out of interpolation, it try to exchange the data and give you the correct answer in between these two. So let's observe few things here. So let's look at the planes, okay, and the fly, okay. So how exactly what is happening we able to see in between, okay. So let's start here, and let me decrease the size, okay, so at least we have an idea, okay. So slowly look, it try to exchange the data. So when whatever is going from here, it look here, it is one-to-one mapping, okay. Now whatever is going from here, it try to enter from here, okay, when it is matching, okay. So look, this is somewhat almost matching class of the things, okay. So more or like it is one-to-one map, it's slightly out of focus, okay. So at that time whatever is coming here, it enter here, then it try to move, okay, and then what happen, same this rotor portions enter, assume that it rotating in this direction, so when it pass through, immediately same portion try to enter from this direction, so it in that regard try to continuously exchange the data, okay. So that is what exactly happening here. So look, it's almost gone, look, it passed through, okay, and next one is entering and exchanging the data, and similar line next one exchanging, and like that way entire rotor and the stator coupling we able to manage, okay. So try to solve for 1 second and look at how exactly the data exchange is happening, and it is I say very nice tutorial to explore. Even without any one-to-one mapping, one can exchange the data with the help of this overlap GGI.